So now we are going to calculate how the method for oxidation number. Check out here on the slide what we have. Oxidation number of Mn in KMnO₄, chromium in K₂Cr₂O₄, 7, phosphorus oxidation number in H₃PO₄, and sulfur in Na₂SO₄. So what is the procedure for that? I'll explain it to you over here. See, what we need to do understand is sum of oxidation number of all atoms equals to sum of oxidation number of all atoms equals to 0. This is for neutral molecule. Alright. And if it is an ion, then sum of oxidation number of all atoms equals to charge on the ion. Alright. Sum of oxidation number of all atoms equals to 0 for a neutral molecule, whereas sum of oxidation number of all atoms equals to the total charge on the ion. Alright. Just remember these 2 points, and as you already know that we have to remember few things, such as for an element in its natural state, example hydrogen in H2, phosphorus in P4, sulfur in S8, chlorine in Cl2 will have oxidation number 0. Hydrogen when with metals has -1, when with non-metals has +1. Group 1 elements will always have +1. Group 2 elements will always have +2. Halogens commonly have -1. Oxygen usually has -2. Alright. So using these points plus this, you can easily calculate oxidation number of any atom that you need. Alright. Let's see. Come. If I have to calculate oxidation number of Mn in KMnO₄, alright. So I know what I will do is, let's suppose oxidation number of Mn is X. Alright. So what I'll do, it is a neutral molecule. I'll add oxidation number of all atoms and put it to 0. I have taken oxidation state of manganese as X, oxidation number or oxidation number of Mn. X is oxidation number of Mn. Alright. Now I'll use the summation of oxidation number of all atoms equals to 0 because it is neutral. So oxidation number of potassium is +1. One atom is there, so +1. Mn, it is X. And for oxygen, oxidation number of oxygen mostly has value of -2. So we have 4 atoms. So 4 into -2, and it is a neutral molecule. So this is 0. Alright. So what we will have, +1 plus X. 4 into -2 is -8. And that is equals to 0. What do you have? What do you have? X +1 and -8, that is -7 equals to 0. So X comes out to be +7. So oxidation number of Mn out here in KMnO₄ is +7. Similarly, I hope you understood everything. Similarly, I'll take another example. Let me take an example where an ion is here. Let me tell you Na₂SO₄. I'll pick a Na₂SO₄. Right. What you can do is, either you find out oxidation number in Na₂SO₄, or you can find out oxidation number of sulfur in sulfate ion, because you have sulfur in sulfate ion out here. So separately also, if you find out oxidation number of sulfur in sulfate ion, this is sulfate ion. Whatever oxidation number of sulfur in sulfate ion, same will be when sulfate is in a salt. So what is oxidation number? Let's take oxidation number of sulfur out here is X, and oxygen are 4. So 4 into -2, and the total charge on sulfate is -2. So what is it? 4 into -2 is -8. This is -2. So X comes out to be -8 will go that side. So 8 minus 2, that will be +6. So oxidation state of sulfur out here is +6. So in Na₂SO₄ as well, oxidation state of sulfur is plus 6. So this is the method which we will be using to figure out oxidation number in a given molecule or ion. I hope you must have understood by now. We have few more examples out here where we get average or oxidation values. Why we are getting that? We are getting this because, example in carbon suboxide C3O2. Why we are getting fractional? I'll explain it to you. C3O2 has this structure. Alright, this is the structure of C3O2. So what happens is, if we figure out individual carbon oxidation state, what you will have? We have to break bonds. We will break this bond -2 on oxygen +2 on this carbon. Similarly, when we break this bond, both are carbons, so there will be no charges on each other because both are same atoms. So same atom, same electronegativity, no charge on each atom. Similarly, if we break this, no charge on each atom. So this carbon has a zero oxidation state. Similarly, if we break this bond, oxygen has more electronegativity, so it will get -2 and carbon will get +2. For breakage of each bond, more electronegative get -1 and less electronegative gets +1. So here oxygen is more electronegative and two bonds are breaking. For each bond, oxygen gets -1. So there are two bonds breaking. So we have -2 on oxygen and carbon gets +2. So check out this. We have three carbon number 1, carbon number 2 and carbon number 3. So two carbons have +2 value and one carbon has 0 value. When we take average of oxidation number, what we get? 2 plus 0 plus 2 divided by total 3 carbon atoms, and you get the value as 4/3. So actually each carbon atom has non-fractional value. They have complete values +2, 0, +2. They do not have fractions. But when we take average, we are getting a fractional value. So whenever you get a fractional value, that means it is the average value, not the absolute value. So average values, we do get fractional values. For example, when you calculate in S, this is a molecule where S4O6 minus 2, and in this you have 4 sulfur atoms. 2 sulfur atoms are +5 and 2 are 0. When you take average value, what you will get? +5 plus 0 plus 0 plus 5 by 4. So you will get 10/4, that is 2.5 average value, right? So fractional values, or we get in decimals, that means we are getting it because of average values. Otherwise, each sulfur atom will have a definite whole number. Alright, here Br3O8, again you will get a fractional value because we are taking average. And in CrO5, we call this as a blue butterfly because the color of this compound is blue. Alright, so oxidation number in chromium pentaoxide, we have a oxidation number of +6. Alright, and in oxidation number of Fe in Fe₃O₄, it is a combination of FeO and Fe2O3. So in FeO you have oxidation number of +2 and in Fe2O3 you have oxidation number of +3. So Fe₃O₄ is a mixed oxide. So whenever somebody asks you what is the oxidation number of Fe₃O₄, you will have to tell that oxidation number in Fe₃O₄ is +2 and +3, because it is a combination of FeO and Fe2O3. So just remember this so that you will never have any issues in solving questions on redox. That's it.